You're sitting on a small planet, orbiting an ordinary star, and yet you are part of something far bigger than you've ever been told. For centuries we thought the Milky Way was just a glowing stripe in the night sky, a modest swirl of stars. But today we finally know the truth. Our galaxy isn't just wide, it's colossal, over 200,000 light-years across, wrapped in a dark matter halo that stretches nearly 2 million light-years. That means the Milky Way is already brushing against Andromeda, already pulling in smaller galaxies, already preparing for its future collision. And here you are, a single human being, clinging to one tiny world inside this empire of gravity. Tonight, we'll take a step back. Not just to admire the Milky Way, but to understand its true size, its hidden skeleton, and its destiny. Chapter 1. Beyond the Numbers. For centuries, we assumed the Milky Way was a modest spiral island, floating in an otherwise infinite sea, a few tens of thousands of light-years wide, a kind of local town of stars. But those estimates were crude guesses, stitched together with limited tools and narrow imaginations. Today, thanks to missions like Gaia and clever gravitational sleuthing, we finally know our galactic home is not just a small neighborhood, but a sprawling metropolis of unimaginable scale, stretching at least 200,000 light-years across, when you account for its stellar disk, and nearly 2 million light-years, when you factor in the invisible dark matter halo that cocoons it. To put that into perspective, if our solar system were reduced to the size of a single coin, the Milky Way would be the size of North America. Every star you see at night belongs to this one structure, and yet those pinpricks of light account for less than 1% of the galaxy's true sprawl. The rest hides in veils of dust, in tidal streams stripped from smaller galaxies, in dark matter clouds so vast that they weigh more than 90% of the entire Milky Way. We've learned that what we once thought of as the galaxy's edge isn't an edge at all, but more like the blurred shoreline of a continent, still pushing outward, swallowing smaller satellites as it grows. Astronomers mapping the furthest stellar streams have traced them out to 120,000 light-years from the galactic center, twice as far as older textbooks claimed. And beyond even that lies a gravitational dominion reaching halfway to Andromeda, so large that it overlaps with our neighbor's halo, meaning the Milky Way is already brushing shoulders with the galaxy it will one day collide with. Think about what this means. Everything you've ever known, every historical empire, every story, every human, every idea, all of it exists inside a single galactic bubble whose true dimensions are only now being revealed. And it is not a polite bubble, it is a predator. The Sagittarius dwarf galaxy is currently being devoured, its stars shredded into tidal streams that arc around our halo like ghostly scars. The Magellanic Clouds, two companions once thought to orbit safely, are being pulled in too, their gas smeared across space like taffy, fueling new starbirth in our spiral arms. The Milky Way, far from static, is growing, feeding, evolving, and its true size is measured not just in light-years, but in the histories of galaxies it has swallowed. When astronomers finally tallied up the weight of all this stars, dust, gas, and dark matter, they arrived at a staggering figure: 1.5 trillion solar masses. That means if you took 1.5 trillion suns and scattered them into a single gravitational field, you'd have the Milky Way. It is not just our home, it is our empire of gravity. And we are only ants crawling across its floorboards, trying to draw the blueprints of a cathedral we cannot step outside to see. And yet we have begun to succeed. We finally know how big the Milky Way is, and the number is so immense, it rewires what we thought was possible for our place in the universe. Chapter 2. The Hidden Halo. The true size of the Milky Way does not end where the light stops. That faint river of stars you see arcing across a summer sky is only the bright core of a structure that is almost entirely invisible. For decades, astronomers faced a paradox. Stars in the outer disk moved too fast, whipping around the galaxy at speeds that should have flung them into intergalactic space. The visible matter, stars, gas, dust, simply wasn't enough to hold them. The only explanation was that an enormous cocoon of dark matter surrounded our galaxy, providing the extra gravity needed to keep it intact. And when the numbers were crunched, they revealed something shocking. The halo stretches at least 2 million light-years across, 20 times wider than the glowing disk of stars we call the Milky Way. Imagine that. The galaxy we grew up thinking was 100,000 light-years wide, big enough to stagger the imagination, turns out to be the glowing bead at the center of an invisible sphere, so vast it nearly touches Andromeda. In other words, our galaxy is not a single spiral, but a kind of solar system on steroids, a central shining nucleus, orbited by a gravitational cloud, so immense that it blurs into the cosmic web itself. This halo is made of matter we cannot see, cannot touch, cannot photograph. Billions of dark matter particles stream through your body every second, indifferent to your atoms. Yet collectively, they outweigh everything visible in the sky. The Milky Way's size, therefore, is not simply measured in light years but in shadows, in distortions, in the way it bends space-time itself. Recent surveys of satellite galaxies, like the ultra-faint dwarfs discovered in the Sloan Digital Sky Survey, have confirmed this reach. Their orbits can only be explained if they are swimming in a vast invisible ocean of gravity. And so we redefine our galaxy, not as the luminous spiral, but as this entire domain, this empire of dark matter, extending farther than any starlight can trace. What does it mean to live inside something that big? It means that the edge of our galaxy isn't a sharp border but a ghostly fade, where stars become rare and dark matter thins into intergalactic space. It means that the Milky Way is already colliding with its environment, already consuming smaller galaxies, already shaping the space between galaxies themselves. And it means that our cosmic home is not a fragile island, but a leviathan, an ancient gravitational beast, whose reach extends across millions of light years. When we say we finally know how big the Milky Way is, we are not simply bragging about size. We are admitting that the borders of our home overlap with others, that our galaxy is entangled in a cosmic web of interactions, and that one day, this size will dictate our destiny. In about 4 billion years, the full weight of that 2 million light-year halo will crash into Andromeda's, and two giants will merge into a single monstrous galaxy, reshaping the night sky forever. To know the Milky Way's size, then, is to glimpse not just our present, but our future. It is to understand that our home is not a modest spiral, but a galactic empire stretching farther than we dared to believe. Chapter 3. The Stellar Oceans. When we speak of the Milky Way's size, we too often reduce it to sterile numbers. 100,000 light-years, 1.5 trillion solar masses, 400 billion stars, but numbers fail to capture what it really means to live inside such a colossus. The Milky Way is not just wide. It is deep, layered, alive. Its stellar disk alone stretches 100,000 to 130,000 light-years. But that is only the brightly lit stage. Beyond the disk, the galaxy spills outward into a halo of stars and clusters that drift hundreds of thousands of light-years away from the galactic plane, remnants of smaller galaxies shredded by gravity. Imagine a city so vast that its suburbs extend farther than the eye can see, with highways of stellar streams linking its neighborhoods. The Sagittarius stream, for example, wraps around the galaxy in arcs stretching over 360,000 light-years, like scars of ancient conquests. These streams tell us the Milky Way is not static, but expanding by cannibalism, pulling in stars from companions like the Sagittarius dwarf and the Magellanic Clouds. And then there are the globular clusters, over 150 ancient star cities, orbiting the Milky Way like lanterns on invisible chains, some more than 200,000 light-years from the center. Each cluster is a dense ball of 1,000,000 suns, older than Earth itself, fossils of the galaxy's first epochs. Their orbits trace the Milky Way's gravitational skeleton, marking the edges of its true extent. Even within the stellar disk, the scale beggars belief. Our solar system circles the center at 26,000 light-years out, meaning that if the Milky Way were shrunk to the size of the United States, we'd live somewhere around Kansas, far from the bustling hub of downtown, but nowhere near the frontier. The galactic center itself is a maelstrom, stars orbiting Sagittarius A** at speeds up to 7,650 kilometers per s, whipping around an invisible monster 4 million times the mass of the Sun. Yet for all this motion, the galaxy remains coherent because of gravity's invisible architecture. Think of the Milky Way as an ocean, with stars not fixed but flowing, drifting in currents that span tens of thousands of light-years. And in that ocean, our Sun is not a captain, but a passenger, one of 400 billion ships carried along in a tide so vast it takes 250 million years just to complete one orbit around the center. This means that in all of Earth's 4.5 billion-year history, our solar system has completed only 18 galactic orbits. Dinosaurs lived and died during a single galactic season. Humans have existed for less than 1% of one galactic year. And so, the galaxy's size is not just a measurement of space, but of time. To say the Milky Way is 100,000 light-years across is to say that the light from its far side began its journey during the Ice Age, when humans painted caves in France and hunted mammoths on frozen plains. To measure the galaxy's size is to measure history itself, to realize that our tiny species inhabits a structure so enormous that our lifespans vanish against its backdrop like sparks in a storm. Chapter 4: The Warped Disk and the Breathe-In Galaxy. If the Milky Way were nothing more than a flat, static spiral, its size would already be staggering, but reality is stranger and more alive. Our galactic disk is not rigid. It warps and ripples like a sheet of metal struck by a hammer, and this warp stretches the size of the galaxy far beyond its neat textbook boundaries. Observations of distant Cepheid stars reveal that the disk flares upward on one side and downward on the other, creating a cosmic smile that spans tens of thousands of light-years. The warp rotates, too, precessing at 1/200th of a degree every million years, which means that the galaxy itself breathes, flexes, and changes shape on timescales far longer than human history. The causes of this warping are many. The pull of dark matter, the gravitational tug of the Magellanic Clouds, the memory of past collisions with smaller galaxies. This makes the Milky Way not a simple spiral, but a living organism, constantly reshaping itself as it absorbs, digests, and interacts with its cosmic neighbors. And then there is the vertical oscillation of our solar system. Every 33 million years, we bob up and down through the galactic plane like a cork riding waves on a vast cosmic sea. Some scientists even speculate that these passages through denser parts of the disk may correlate with mass extinctions on Earth, as gravitational disturbances kick comets inward or cosmic radiation increases. If that speculation is true, then the galaxy's very size and structure have written the story of life and death on our planet. But the scale grows stranger still when we consider the galaxy's bar, a rigid spine of stars stretching 27,000 light-years across the center. This bar acts like a lever, channeling material inward toward the black hole, driving spiral waves outward, and setting the rhythm of star formation across the disk. It is a structural reminder that the Milky Way is not just wide but also mechanical, an engine of gravity and matter turning on cycles of hundreds of millions of years. The warp and bar together redefine what we mean by size. The Milky Way is not just a disk 100,000 light-years across. It is a dynamic system whose living edges stretch and contract, whose breathing motions extend hundreds of thousands of light-years outward, and whose gravitational field stretches millions of light-years beyond its stars. We finally know that to measure the Milky Way's size is not to draw a boundary, but to trace a heartbeat, to recognize that our galaxy is not a static map, but a moving, evolving storm in the universe. Chapter 5. The Coming Collision. Knowing the size of the Milky Way also means knowing its fate, because in astronomy, size dictates destiny. And our destiny is already written in gravitational ink. The Milky Way is on a direct collision course with the Andromeda galaxy. Right now, Andromeda hangs in the northern sky as a faint smudge, visible even to the naked eye, a quiet blur of light that seems harmless. But that blur contains 1 trillion stars, more than twice our own population, and stretches over 220,000 light-years across. It is rushing toward us at 250,000 miles per hour, so fast that in cosmic terms, the two galaxies are already touching. Their dark matter halos, those enormous invisible cocoons, stretching millions of light-years, overlap today. This means the collision has already begun. Not in a violent smash of stars, but in the slow gravitational handshake of two giants. In about 4 billion years, their stellar disks will collide, unleashing a slow-motion catastrophe that will take 2 billion years to play out. Picture the scale. 2 spirals, each containing hundreds of billions of suns, passing through one another like swarms of fireflies. Stars will not often collide. Space is too empty for that. But gravity will rearrange everything. Spiral arms will shred and twist. Tidal tails will whip outward for hundreds of thousands of light-years, and vast arcs of stars will be flung into intergalactic space. Our sun, 26,000 light-years from the galactic center today, may be hurled into a new orbit, cast to the outer rim of the merged system, or even ejected entirely into the darkness between galaxies. Imagine Earth wandering without a galactic home, drifting as a rogue solar system across the intergalactic void. Meanwhile, at the center of the merged galaxy, the supermassive black holes, Sagittarius A, Asterisk with its 4 million solar masses, and Andromeda's with 100 million, will spiral toward each other in a deadly waltz, releasing more energy and gravitational waves than all the stars of both galaxies will radiate in their lifetimes. The end result, billions of years later, will be a new galaxy, a massive elliptical system astronomers have nicknamed Milkomeda or Milkdromeda, spanning perhaps 600,000 light-years, 3 times the current size of the Milky Way. Our spiral arms will be gone, replaced by a bloated football-shaped cloud of stars, slowly fading into old age. And yet, the collision will also spark furious bursts of star formation, lighting up the skies of any surviving worlds with clusters of brilliant blue giants. From our perspective today, this coming merger is not a doomsday. It is a natural part of galactic evolution. It is how galaxies grow, how they reshape themselves, how the universe recycles matter on scales too vast for us to comprehend. To know the Milky Way's size, then, is not only to map its edges, but to glimpse its future. A future where our galaxy is not alone, but part of a grander union, its true size multiplied through collision, consumption, and transformation. We began by asking how big the Milky Way really is, and the answer defies simplicity. It is 100,000 light-years wide in the visible disk, but 2 million light-years across when you include its dark matter halo. It contains 400 billion stars, 150 globular clusters, dozens of tidal streams, and over 30 companion galaxies. Its weight is 1.5 trillion solar masses, but numbers are only the skeleton of the truth. The Milky Way is not just large, it is alive, evolving, warping, feeding, colliding, and preparing for its future transformation into something new. We finally know how big the Milky Way is, and that knowledge changes everything, because it forces us to recognize our place. We are not the center, we are not even close. We are passengers on the outskirts of a spiral arm, clinging to a small yellow star in a suburban neighborhood of a galaxy that is itself just one among 2 trillion others. And yet, there is something profoundly human in this realization, that we, tiny sparks of consciousness on a pale blue dot, have measured the size of our galaxy from the inside. We cannot step outside to see it, but through ingenuity, persistence, and imagination, we have mapped its shape, weighed its mass, traced its invisible halo, and glimpsed its destiny. We are, in every sense, citizens of a galaxy. The Milky Way is our country, our continent, our ocean, our cathedral. It is vast beyond comprehension, but it is also home, and though it will one day merge, transform, and fade into the larger story of the universe, for now, it belongs to us, and we to it. So now you know, the Milky Way isn't just a stripe of stars in the night sky. It's a titan, 2 million light-years wide, 1.5 trillion suns in mass, already colliding with neighbors, already shaping the future of our cosmic home. And you are part of it. Every breath you take, every step you make, unfolds inside this vast spinning cathedral of stars. We finally know how big the Milky Way is, and the truth is, it's bigger than we ever dared to imagine.